Welcome back, dear students. Let us discuss third part of this lesson, which cover test statistic and some parametric tests. Testing the significance of some population parameters, in which hypothesis testing is a procedure based on sample evidence and probability. It used to test claims regarding a characteristics of a population. A hypothesis is a claim or a statement about a characteristic of a population which is of interest. A hypothesis test is a way to use sample statistic to test a specific claim. For example, if the population mean weight is known to be 157 pounds, then the test claim that the mean weight has to increase. Now discuss on test statistic for significance of single mean when sample size is small. If the sample size is small, the test is on verification about the significance of single mean. Then we have to make use of a test statistic which is called T. X bar minus mu by small s by root n follows T n minus 1 degrees of freedom, where x bar is the sample mean, mu is the population mean, n is the sample size and s is the sample standard deviation. Coming to the next text, that is test statistic for the significance of the difference of means when the sample sizes are small. In this, the test statistic deals with x1 bar minus x2 bar minus mu1 minus mu2 root over small s1 square by n1 plus small s2 square by n2 follows T n1 plus n2 minus 2 degrees of freedom, where we have x1 bar and x2 bar are the two sample means of first and second groups, and mu1 mu2 are the two population means, n1 and n2 are the sample sizes, s1 and s2 are the sample standard deviations of first and second groups. Coming to the next test statistic, it is meant for significance of single mean when the sample size is large. If the test is on verification about significance of single mean, sample size is large, then the test statistics is defined as z equal to x bar minus mu by s by root n follows normal distribution with mean 0 and variance 1, where x bar is the sample mean, mu is the population mean, n is the sample size and s is the sample standard deviation. Coming to the next statistic, which can speak about significance of difference between means. So, if the test statistic is verifying the significance of difference between two population means, the sample sizes are large, that means n1 and n2 are more than 30, then the test statistic is defined as x1 bar minus x2 bar minus mu1 minus mu2 follows root over s1 square by n1 plus s2 square by n2 follows normal distribution with mean 0 and variance 1, which means that it is a standard normal distribution, where you know that x1 bar x2 bar are the sample means and mu1 mu2 are the population means, n1 n2 are the sample sizes of first and second groups drawn from two populations, and s1 s2 are the sample standard deviation belong to first and second groups. Coming to the next statistic, which mostly deals with small samples for paired data. If the test is on verification about the significance of difference between two population means with the paired samples or correlated samples or dependent samples, sample sizes are small, then the test statistic is defined as T equal to d bar by sd by root over n follows T n minus 1, where you know that d bar is the mean sample deviation from first and second samples, d is nothing but x minus y, mu is the population mean and n is the sample size, sd is the deviation stated sample standard deviation. Test statistic for the significance of correlation coefficient when the sample size is small, again it is a distribution with T distribution. If the test is for verifying the significance of correlation coefficient between the variables and the sample size is small, then the test statistic is T, which is defined as r root over n minus 2 by root over 1 minus r square follows t n minus 2 degrees of freedom, where r is the sample correlation coefficient and n is the sample size. Test statistic for significance of the single proportion when the sample size is large. It is again standard normal distribution application. If the test is on verification about the significance of single proportion, then the test statistic is defined as p cap minus capital P by root over capital P capital Q by n, which follows standard normal distribution with mean 0 and variance 1, where p cap is the sample proportion, capital P is the population proportion, and Q is 1 minus p, small n is the sample size. Coming to the test statistic for the significance of difference between two population proportions when sample size is large. If the test is sample to verify the significance of difference between two population proportions, then test statistic is defined as G equal to P1 cap minus P2 cap by root over P1 Q1 by N1 plus P2 Q2 by N2 follows standard normal distribution with mean 0 and variance 1, where P1 cap and P2 cap are the sample proportions of first and second groups. P1 P2 capital P2 are the two population proportions. Small n1 and small n2 are the sample sizes of first and second groups. When the test statistic about significance of single variance when the sample size is small, which follows chi-square. If the test is on verification about significance of single variance with the small sample sizes, then the test statistic is chi-square equal to ns square by sigma square follows chi-square n minus 1 degrees of freedom, where s square is the sample variance, n is the sample size, sigma square is the population variance. Whereas the test statistic for significance of difference between two population variances when the sample sizes are small, then the test statistic is s1 square by s2 square follows f of n1 minus 1 comma n2 minus 1. It is Snedeker's F distribution, which is another sampling distribution. Coming to the values what we have used in F statistic, S1 square, S2 square are the sample variances, N1, N2 are the sample sizes of two populations. Dear students, in this lesson we have discussed about overview of statistical inference and hypothesis testing, in which part 1 deals with statistical inference and part 2 deals with details description of parametric hypothesis, and part 3 deals with different test statistics under the environment of small and large sample sizes. Dear students, I hope you are clear about different concepts of this lesson. These topics are very much useful in your research. Hope you can make use of this one. I would like to conclude this lesson on overview of statistical inference and parametric testing. Thank you.